Okay, everybody, I put together something on regression, and it's really nice because the basis of it is right in your book, in the Pro Copy book, and I seriously didn't realize it was there. But this is on page, wow, wait a minute. It's on page 89, page 41 and 42. Okay, on regression, and we've got some data here. This is what the whole project for CVP was based on, and this is a interdisciplinary business student organization has a seminar, and they need to break it down into variable and fixed costs. So we've got 8 semesters worth of data, and these are our attendees, and these are the total costs of the seminar. Okay, and so what we could do is we could use account analysis, and based on the costs themselves and experience, we could figure out what was fixed, variable, and mixed, okay? Or we could use the high-low method. All right, so let's do that and see what this looks like. So here it is. Here is our data, and our high number of attendees was in I think it's term, isn't it, 6? And then the low was 46. So we can do a high-low method here, and $10,000 minus $5,900 gives me a change of $4,100, and 146 minus 46 is 100. So our variable cost is $41. Okay, $41 per attendee. Okay, so if I take that off, then that gives me my fixed cost of 4014, and I've got a cost function that y equals 4014 plus 41x. Okay, so that's great. That's good. Then what I did is I took the data and just graphed it. I threw a graph in here in Excel, and that's just an estimate of what I think my fixed cost might be. You know, it's right around there. It might be a little bit lower. You're probably a smidge lower because 5,000 is right there. So, but I didn't want it to be on top of that line. So there's my fixed cost, and then my variable, I just drew a line from the intercept up to the highest point. Okay, and one of the first things you want to notice is there's not much variance around the line, is there? This one's probably the farthest away, but generally the observations are right around this line. So me personally, I think it looks pretty good. Okay, I think it looks like it specifies the function pretty well. It's linear within the relevant range. That's one of the things we look for. Okay, so now on the next page in the Pro Copy book on page 42 are regression results. And these are the regression results here. Okay, and the first thing I look at is the R-square. All right, and it's called the coefficient of determination. 1.0 is perfect, so this is very good. Okay, this tells us that the regression, that the variable of number of attendees accounts for 88% of the variance. It explains 88%. That's very, very good. Okay, so that's fine. Now let's look at our data. And I don't mean, a lot of people don't understand this. That's why I wanted to go through it. So this is the high-low cost function. I'm up here on top, high-low cost function. And I want to compare that to the regression one. Okay, so the intercept right here, that is our fixed cost. Okay, it compares to the 4014 that we had in the with the high-low method, so they're very close. Okay, and the x variable 38.76, that's the variable cost. So the high-low cost function is y equals 4014. For regression, it's 4031 plus, where did it go? 38, say 39x. I think that's terrific. You know, I think it's just fine. And you can see there's a big similarity between the high-low and the regression. So based on what we've seen so far, it's a good fit. Okay, it's good. And then the standard error here tells us how much of the value is likely to be affected by random errors. All right, and this is compared to our coefficient here of 38, 5 is low, 5.6, that's low, so it's not much. Okay, you don't have the p-value tells us that it is very significant, all right? Don't worry about that so much, and don't worry about the upper and lower 95%. But this, you see the relationship though? This is what I wanted you to see, is just the relationship between the high-low and what the regression is telling us. You know, and it tells us that, you know, the standard error of the variable is low, and when we look at the distribution around this line, it is low. You know, some of these two values here are just about on the line, the three of them are, and the other ones are pretty close. All right? So what else did I have to tell you? Is that it? That should be all you need to know. All right? But I like the idea that you can look at data and you can look at a line and you can tell whether or not it's kind of reasonable. Like this is a nice linear function, okay, within the relevant range. That's all we really have to care about, you know. So page 41 and 42. Some of the measures, so linearity within the relevant range. This is all in the Pro Copy book. That's the first one. Constant variance of the residuals, and we use the Durbin-Watson statistic, and I read quite a bit about it. I don't think this existed when I went to school anyway, but there's a lot of discussion, and it depends on what kind of data you have, but I did find this handy thing that a rule of thumb is that the test statistic values in the range of 1.5 to 2.5 are relatively normal. Okay, so that's good. We don't have, excuse me, a Durbin-Watson stat here, but that's okay. All right, just so that you understand that, that would be one way to look for independence of the residuals. Okay, yeah. What else? And then we've got what? Independence of the, Durbin-Watson, constant variance of the residuals. That assumes a uniform scatter or dispersion of the data points around the regression line, and we have that. Okay, so based on everything we're seeing here, this is a pretty good fit, for the data. Okay, and the high-low method confirms the regression. So I hope this helps a little bit. Okay, it should make it just clear. I think it got muddier when we did multiple regression, and just think of what they did there as they looked at the individual variables separately, and then they looked at it as a multiple in a multiple regression. I think that might have been where it was confusing. So if I think of anything else here that's helpful, or if you do, let me know. Okay.